All right. Well, this is another momentum problem. We've got a gun that shoots a bullet, and the bullet strikes a stationary wooden block, and it embeds itself into the block. So here we go. Let's see if we can draw a gun. I don't know. I'm not too good at this. Okay, there we go. And the bullet comes out of the gun, and the bullet enters a wooden block. Now the wooden block is on a frictionless surface here. And so this is the, let's call this the before picture. And the after picture is going to be kind of like this. Here is the after picture. So the bullet, it's just basically this dash here that I've drawn here, right there. The bullet is inside the wooden block, and now they go off together. Okay? So let's call this VB, velocity of the bullet. Let's call this velocity of the wood. And by the way, the velocity of the wood is originally 0. So the wood, this wooden block here is not originally moving. The velocity of the bullet, well, that's what we're going to try and figure out. What is the original velocity of the bullet? But we do know that the velocity of the combination, okay, or another word we use for this is couple. So I'm going to use the subscript C. The velocity of the couple turns out to be 8.6 meters per second. And we need the masses. So the mass of the bullet is, let's see, 35 grams, which is 0.035 kilograms. And the mass of the wood is equal to 5 kilograms. Oops. Let's try that again. 5 kilograms. Okay, so this thing here is, oh, now it looks like the bullet's in there beforehand. Let me erase that. So the wood is 5 kilos. So together they're 5.035. Okay, not a lot more. The question is, how do we figure out this? Okay, so let's go ahead and do our conservation of momentum. That's how we do all these momentum problems. And we're going to say initially, what's moving? Well, initially we have the momentum of the bullet. Now, is the block moving initially? No, it's not. So it has no momentum. So we can leave that off. So we can say that is equal to, now, afterwards, they form a couple. So it's the mass of the bullet and the mass of the wood together. Now, in this case, by the way, if you happen to get this wrong, if you happen to only put mass of the wood, you'll actually pretty much get the right answer. But please be aware, that would be the wrong way to do it. Why would that happen? Well, take a look at the difference between the masses. This is 5 kilos, and this is 0.035. When you add them up, you get that. So therefore, if you made a mistake and you only wrote MW here, okay, in this part of the equation, you'd get just 5, which is pretty close to 5.05. So guess what? Your final answer is going to be pretty right. But once again, that would still be wrong. I mean, you do a different problem where you have a couple situation, and if their masses were not so drastically different, you wouldn't get the right answer. Okay, let's continue. Now that's going to be the velocity of multiplied by the velocity of the couple. So understand that this combination mass is your final mass multiplied by your final velocity. What we want to find is the velocity of the bullet originally. Therefore, we have to do a little bit of algebra and divide this by the mass of the bullet. Now, if we stick in the values, we're going to get 5.035 kilos here and multiplied by final velocity right there of 8.6 for VC. Divided by mass of the bullet, once again. And let's see if we can figure out what this is. Get our calculator out. And we're going to go 5.035, enter, 8.6 times 0.035 divided by. And we're getting 1,237. So, let's write that down. 1,237 meters per second is the original velocity of the bullet. So this can actually be used in real life to calculate the velocity, like the launch velocity of a bullet, because it's really hard to measure the velocity of a bullet in real life because it's moving so fast. But once it enters a known mass, this number is a lot easier to measure. And so if you know the ratio of their masses, as we do here, you can actually figure out the original velocity of the bullet. Hey, thanks for watching. See you next time.